In today's video, we're going to be going over my complete visual effects workflow using Blender, Nuke, and DaVinci Resolve. I've had a lot of requests to make this video and I wanted to make sure that I made it right. So I've got no idea how long this video is going to be. I'm going to keep it comprehensive, so I'll talk about every stage of the process. So earlier today I went out and I shot a piece of footage that I'm going to turn into a visual effects shot. And now literally in this video I'm going to start from scratch and start working on it. So step number one before I actually do anything with the footage is I create a folder structure for all of my projects. And I have a way of doing that that's quite cool. So I've got something on Google Docs here. This is the formatting for my folder structure. Basically, the way it works is I have some edit folders at the top. This is for where the footage goes, where the exports go, the DaVinci Resolve project, and then for the thumbnail. And then after that, this is all the visual effects stuff. So we have shot 0, and then I've got shot 1, shot 2, blah, blah, blah. And for each of these, it will create a Nuke folder, and then it will also create a Blender folder. So depending on how many shots there are, for example, in this shot that I'm about to do, it's just one shot. So I'm going to go down until I've got all of shot 1 and all the edit folders and everything. I'm going to press Control-C, and then I'm going to open a Notepad document, paste it in here, and this is how it needs to be formatted so that Windows knows how to create the folder structure correctly. So then I'm going to do Control-Shift-S to do Save As. I'm going to create a new shot folder, so I'm going to call this VFX Workflow. And then inside of here, I'm going to call this Shot Creator, doesn't matter what you call it. And then you have to do .bat on the end, which saves it as a .batch file. And then if I close this and I go to that folder and I open the VFX Workflow, double click this, and then it's going to run the commands, and now it's going to create all the shot folders for me. So that's a semi-automated way of making all the folders for all the projects each time. And I now do this for all of my videos, and it's really handy. So now that that's done, we can put the footage into the shot folder. So I'm going to grab it off the hard drive and I'm going to paste it into here, which is going to save it in the edit folder. And then the next stage is to open DaVinci Resolve and start doing the edit. This isn't my usual DaVinci layout. I normally have the playback on this monitor over here actually, but for this I'm going to have it all on the same screen. So first thing is first, go to Import Media and I bring in the footage. Once that's in the timeline, I'm going to chuck it out as an EXR sequence to Nuke. So the way I do that is I go into the Deliver tab. I'm going to create a name for my shot and then choose where it goes. And in this case, I'm going to go in the shot 1 folder that I made, Nuke, live action, and then save it here and press save. Then for the format here, I'm going to change this to an EXR sequence, which is commonly used in visual effects. I'm going to go RGB zip compression half. The resolution, I'm going to downscale from 4K, which it is in the timeline, to 1080p, just because it's a little bit less heavy to work on. And I think that is everything. So I'm going to press add to render queue and then start render. Then once that's exported, the next step is I'm going to jump into Nuke and bring in the sequence that I've just exported. I'll also point out that because I exported this as a 16-bit EXR, I have all the exposure range still in the sky. So if I turn the brightness right down, you can see that all the range is still there. If I'd exported this as a JPEG sequence, I wouldn't have the ability to darken this down and preserve any of the detail in the sky. So once I have my EXR sequence in Nuke, I just do a couple of things before I go to Blender. The first thing is I remove the lens distortion from the shot. Lens distortion is really important with VFX, and it's something that I've never seen anyone make a good video about on YouTube. Basically, if you've ever seen some GoPro footage and all the edges of the screen are really curved, it's because it's a really wide angle lens. So in visual effects software, what you can do is called undistorting, which basically accounts for the lens distortion and bends the footage back the other way. There's a few ways you can do this. You can analyze the footage and the computer will do its best to work it out automatically. The really professional way to do it is to shoot something called a lens grid, which is a massive piece of card like this. And because these are all perfectly straight lines on the grid, when you shoot it on a camera, you can see how much the lines are bending, and then that allows you to calculate the lens distortion. I don't actually have a lens grid, so what I do is a process where you draw some straight lines onto the footage and tell the computer this should be straight. But I know I shot this on a 24mm lens, and I've got presets for all of my lenses that I've made before because I do this quite often. So if I just search for my 24mm preset, this is a setup that I made before that is removing the lens distortion for that particular focal length. You can see it's fairly subtle. This isn't a super wide lens, so it's not going to be too much distortion anyway. And what it's doing is stretching the footage out a little bit more. So you can see the edge of the footage goes from here to here. In visual effects, this is what's known as overscan, and it's the extra pixels that get stretched off the edge of the frame and go outside of the footage area basically. So now we've done that, I can export this as an image sequence to Blender and I can use it as the background to my camera and set all of my scene up. So I hit render now and then render input sequence. Then once that's finished, I also export a second JPEG sequence at a much lower resolution. So if I add a reformat node and just scale this down, I usually scale it down to about 0.4. And this changes the resolution from 1920 by 1080, which is HD, to 768 by 432. So pretty much 480p. And the reason for this is even on a pretty good computer, HD background images in Blender don't play back very well if you set them up as a background image through your camera. So I export a lower resolution one that I can use as my background image so that it plays back nicer. So I'm going to create a second write node that's doing a very similar thing, and I'm going to hit render on this as well. Okay, that's finished. Now we can jump into Blender. I'm going to open the movie clip editor and motion track the footage first. And the first step of that is to bring in the undistorted plate, not the background plate. And then I can select them all, press open clip, and then I've got my footage. From here, I hit set scene frames and then prefetch, which will load it into my RAM. And then I start motion tracking. Okay, so I've got a solve error of 0.27, which is pretty good. So I'm going to go into the 3D viewport and start setting up my tracking scene. So I'm going to do setup tracking scene, look at it through the camera view, and then I'm going to set these as the floor. I'm going to set this as my origin, and then I'll do the rest manually. You might notice when I'm playing through that the playback is really stuttery. That's because at the moment the tracking scene is using the UD plate. So if I go into the camera settings and open background image, and then I set it to use the BG sequence, which I exported at 480p instead, it should play back a lot more smoothly. So then I'm going to rotate the whole scene until the X and Y axis line up a bit better. So let's go for something like that. Then I'm just going to move the plane, scale it up to be the same sort of size as the ground. Something like that. Looks pretty good. The track's looking pretty solid, which is always nice to see. So at this point I would bring in some CG, and in this case I'm just going to do a TIE fighter because I've been watching The Mandalorian and I'm in a very Star Warsy mood. Then to get the lighting to look good, I always use an HDRI instead of lights in Blender because it looks a lot more realistic for VFX. So I'm going to bring in an environment texture, and then just to fine tune it, if I turn off the display of the background image in the camera, now I can work out where the sun is and put it in the correct direction. So currently the sun is definitely in the wrong place. The sunset was kind of over here in the actual footage that I shot. So I'm just going to rotate that until it's kind of in the correct position. That looks pretty good. Maybe about there. So now at this point it's time to do the overscan, which I was talking about in Nuke before. The original resolution of this was 1920 by 1080, and then with the lens distortion it gets overscanned to 1954 by 1099. There's an overscan add-on for Blender that you can download that I'll leave a link to in the description as well. It's really simple to install, just install it like any other add-on in Blender, and then once it's installed it will appear over here in the Dimensions tab. Turn on use overscan, and then in here you put the resolution of the overscan plate, so 1954 by 1099. Usually I do times 0.102 on both of these as well, just to add a little bit more just in case, because sometimes you need a bit more than you think in Nuke. And that's actually changed our camera size in Blender, so if I turn this on and off you can see that it's changing ever so slightly. So this will allow us to render our CG at the same resolution as the undistorted overscan plate. For rendering in Blender, instead of using the normal output tab, I do it through the compositor, because that way it's much easier to set up for more advanced renders. So I have a file output node, and I'll set this render layer to be called TIE Fighter, and then it should appear here. So this is the render layer I'm currently using. And then I'm using a file output node to output all of these passes. And the reason for this is because I renamed some of them, like image gets renamed to RGBA so that it's more compatible with Nuke. If you don't rename it to RGBA, then the default channel in Nuke will be black. When you bring in the CG, you won't see anything, so it's kind of annoying. This is a way to get around that so that when you bring it in, it looks correct. I also render a mist pass, which is what I use for depth. And then depending on what else I'm rendering, I'll do some other ones as well. So for this, I'm going to do the diffuse and the glossy, direct, indirect, and color. I probably won't use emission because there's no lights on this model. All of these passes get enabled in the render layers tab, and you can turn them all on and off by ticking these boxes like so. And I also turn on denoising data. For the main RGB channel, I use optics denoising now. I use it for pretty much everything now because you can render at lower samples and it still looks good. So I run the image into there and then also use the denoising normal and albedo. And then the denoised image goes into the RGBA input on the file output node. So I'm going to set where this is going to go. And in this case, it's going to go into the Blender folder in renders. So shot 1, Blender, renders. And I'm going to make a folder. I'm just going to call this TIE Fighter. And under the properties, I've set this to be an OpenEXR multi-layer. So we're rendering it to EXRs just like we did from Nuke. For the color depth, I'm going to set it to half because there's no passes that need any high precision color detail. Codec zip lossless. Then I'm going to create a second render layer that's going to be for the shadow. So I'm going to add a new view layer and I'm going to call this shadow. And then I'm going to select shadow down here. And I'm going to make another file output node, or just duplicate the old one. Take the image output from the shadows render layer and plug it into RGBA. And then I'm going to go to where this is being saved, make a new folder called shadows. And then those two are ready to go. And when I hit render, it's going to render both of those at the same time and put them in the corresponding folders, which is really handy. So now to set up the holdouts and things. In the first TIE Fighter layer, I'm going to set the floor and move it into a collection called floor. Then I'm going to select the TIE Fighter, press M and move this into a new collection called TIE Fighter. Then in the TIE Fighter render layer, I'm going to set the floor to be a holdout. And in the shadows layer, I'm going to set the TIE Fighter to be set indirect only, which means it will cast shadows, but it won't appear in the render. Then once that's rendered, what you can do is jump into Nuke and start compositing. I had to take a break because I'm losing my voice. That's how much I've talked in this video. Let's read in the EXR sequences that we rendered from Blender. I only rendered one frame for now, but I'll re-render the whole thing at some point so I can actually play it in this video. We have our shadow, which is just an alpha channel. We have our TIE fighter. The first order of business is applying our lens distortion onto the CG. As you can see, these are rendered at the overscan resolution, which I was talking about earlier. So what we want to do is scale these down to the same size as the background image, which is 1080p, 1920 by 1080. So what I'm going to do is add a reformat node onto the CG. I'm going to change the resize type to none. And as you can see now, this is 1920 by 1080. What it's done is scaled it up from the center slightly to make it fit, and it's cropped the edges. So we've now lost that overscan, even though it is still technically there. What you can do to fix that is turn on this box called Preserve Bounding Box. If I make this bigger, you can see it properly. If you turn this on, it will preserve the bounding box, and any of the pixels that get scaled up outside of this will be retained. If you leave it off, it actually crops them out, which is what you don't want. Then once that's done, you take the lens distortion node you use to undistort the footage, copy and paste this underneath the reformat node, and then we want to do the inverse of what this is currently doing, because at the moment it's trying to undistort the CG. What we want to do is redistort it so it applies the lens distortion. So you turn off the undistort box in the lens distortion node, and now as you can see, it's applying the lens distortion. It's not massively obvious in this because lens distortion mostly occurs at the edges of the frame, but if I toggle it on and off, you can see that it is doing a bit towards the edges of the TIE fighter. So then what you can do is start to merge this over the background footage. It's important to do this over the original, don't do it over the undistorted, and that's very counterintuitive. So this is what that looks like. Then we also want to put our lens distortion on the shadow, and now if I look at the shadow alpha, it looks like this. And then to use the shadow pass, I add a grade node onto the footage, and then I use the alpha of the CG shadow to grade this down, which does this. And then on top of that goes the TIE fighter. The shadow is pretty subtle, but you can see what it's doing there. To start pulling the CG around a little bit more and playing with the different passes, there's a couple of methods you can do. The first one is a full shader rebuild, which looks a little bit like this. This is one that I set up that uses the render passes from Blender and splits them out into the appropriate sections, and then you can grade them all individually. So this is our CG render. It splits them out into your diffuse and your glossy and the direct, indirect, and color for each of those. And then once you've made the adjustments you like, they all get plussed back together and essentially recombined back into the final image, which looks like this. So that's one way of doing it, but there's another slightly easier way that I kind of prefer these days that looks a little bit less crazy. And that's just shuffling out the passes you want to change. So let's say I want to change the glossy direct. I can shuffle out the glossy direct like this, and then I'm going to use a from operation to take this away from the original beauty image, like so. So basically this has taken all the glossy direct pass out of the original beauty image. Then you can add a grade onto here and make any adjustments you want to make, like let's say I want it to be a bit less shiny, so it takes the gain down a little bit. And then you plus this back on top later on. And because we're taking it away here and then putting it back on top here, we're combining it into the full image again, but with the adjusted colors. And then just to make sure I haven't wrecked any of the edges or the alpha, I unpremult it at this point, and then I add a copy node and copy in the original alpha from the CG like so. And then add a premult node under this, and then it should be back to normal. At this point, I usually go in and start doing things like adjusting the black point to match the footage and doing some basic color correction. This compositing obviously looks pretty terrible right now. I did a bit more comp on it, I put some light wrap and stuff on it, but still it's pretty rough, doesn't look particularly good. Then at this point, I add a crop node, and then I write it back out to DaVinci Resolve and bring it back into the edit. Hit render, press OK. So in DaVinci, I'm going to go import media. If I drop this on top of the original footage, and then I can sort of turn it on and off, and you can see they look exactly the same up here, minus the TIE fighter. And then really the final step is just doing any color correction or color grading that I want to do. So for example, I would probably bring the sky down a bit because it's a bit mental. So if I do a luma key, I can play around with some of this. And just like that, with a bit of magic, we've got some sky detail back, which looks nice. So that's my color grade, nothing too crazy. I've just kind of brought the sky down a bit and put a vignette on it really. And then the grade is the final step, and then basically I go to the deliver page and export it to YouTube. So that's the entirety of my VFX workflow, going from bringing in the footage to exporting it to YouTube at the other end. Like I said, that's using DaVinci Resolve, Nuke and Blender. Those are the three pieces of software that I use. All of those are free as well. Blender is obviously free. I use the free version of DaVinci Resolve because it's still super powerful. And I use the non-commercial version of Nuke. So if anyone's interested in adopting this workflow, it won't cost you anything. I think this might be quite a long video once it's edited, but hopefully that's a good overview over the whole process, and you probably learned one or two things along the way. Thank you very much for watching. Leave a like and subscribe if you enjoyed, and I'll see you next time.